Lesson 6.6, we are going to talk about solving equations with exponentials and logarithms, okay, and even the natural log sooner or later, okay. What I want you to do, underline the bases. Again, how do I know those are the bases? They hold the exponent. They're our big number here, okay. Right now, we're kind of stuck in solving because we can't get to our exponents right now. If we rewrote in logarithmic form, it would get us all sorts of messed up. Okay, so what I want us to do is we want to see if we can make the bases the same. Okay, we're going to look for common bases. Go ahead and write off to the side common bases. Okay, we want to try and make those bases the same to help us solve the equation. So take a look at the smallest base. Which one's my smallest base? 2. Okay, I want to see, can I change my bigger base into the smaller base? So is there a way I can take 4 and have 2? 2 to what power? I would, but I want to write it as a power. 2 to what power will get me 4? 2 squared. And then I still have that 3x. So what just happened there is this replaced the 4. Okay, because if I went back, do you agree I would get back to 4 to the 3x? Yeah. Okay, so we didn't do anything with the left side, so I'm just going to keep her there. Let's clean it up a little bit. Look at that right side. How can I clean it up? Specifically, what can I do with this? Distribute, right? 2 to the 2 times 3x? 6x. Okay. Now take a look at your bases. What do you notice? They're the same. And we have this equal sign here. So what do you know about the exponents of those if the bases are the same? And they're in an equation. They would have to be the same thing, right? So what's nice, once you have common bases, you can just cancel them out. And then we're left with the exponents. X plus 7 equals 6x. Because we know if the bases are the same, then we know their exponents have to be the same in an equation. Okay, so this just turned into a basic algebra problem. I could, but I want to get all the x's on one side. So let's subtract x on both sides. So we have 7 equals 6x minus 1x is 5x. What's my last step here? Divide by 5. I know this doesn't come out very nicely, but we're just going to leave this as x equals 7 over 5. Okay, so how we did that is we turned them into common bases. Once you have them into common bases, then you know that those exponents have to turn out to be the same thing. Okay, so let's take a look at example 1a that is in your notes, and I need to rewrite mine. You have 25 to the 3x equals 125 to the x plus 2. This is your example 1a. Okay, so underline your bases. What are they? 25 and 125. See if we can turn the bigger one into a base of the smaller one. How? Okay, I'm going to ask you this first. Can I take 25 to some power? Not 0. Can I take 25 to some power to get me 125? Yeah. Okay, type 25 times 25 times 25.
No, because if you're asking us to do that.
It is no, right? What are you thinking, though? What do you get if you take 25 times 3? You get 75. Sorry, if you get 25 times 5. You get 125. But is that what this exponent means? No. Okay, so don't get to thinking like that. So we cannot turn 125 into base 25. What do you think we do if we don't do that? What did you say? We cannot, because we have to change the bases, so it's based off of the exponents. So if we can't turn the smaller one into, if we can't turn the bigger one into the smaller one, then we have to change both of them. Okay, so let's focus on our smaller one first. How can I write this as an exponent, a base with an exponent? Look at your perfect squares list over there. Is 25 a perfect square? What's the square root of 25? 5. So I can rewrite 25 as 5 squared, because 5 times 5 gives me back to 25. So 25 turns into 5 squared to the 3x. Equals, well, can I turn 125 into base 5? How many times do I have to multiply 5 to get 125? Keep typing 5. 5 times 5 times 5.
How many times?
How many times does it take?
Oh, that's your question.
How many times does it take to get to 125? It's 3. So 5 to the third, and then we still have that x plus 2. Okay, so the reason we can do that is because 5 squared gets us back to 25. 5 to the third gets us back to 125. Okay, and now, what do we need to do to clean it up a little bit? Fix those exponents. Yep, we have 5 to the, what's that turn into? 6x equals 5. What's going to have to happen here? We got to distribute to both. So we have 3 times x is 3x. 3 times 2 is 6. Now, what do you notice? Bases are the same, so now we can cancel them out. That's the whole point of trying to get common bases, so that we can get them gone. So this turns into 6x equals 3x plus 6. Now it's a basic algebra problem. How do I solve? Subtract 3x. So we have 3x equals 6. Last step. Divide by 3. We get x equals 2. Okay. I'm going to look at B, but I'm going to change it to make it look a little bit nicer. Change this to 100 equals 10 to the x. What are my bases here right now? 10 and 100. Why is 100 also considered a base? What's its exponent right now? It's technically, it has that one exponent there. Okay, so 100 is a base. Can I turn 100 into base 10? How? Right, I can turn 100 into 10 squared, and then I still have 10 to the x on this side. So, what's nice that happens here? 10s cancel, so what's left? Right, we have that 2 equals x. Do I have to do any solving here? No, because x is already by itself, so that one worked out pretty nice. Okay, those of you watching the video, I just noticed I changed your problem. This was a 6x to start. So, if I came over here, does that change how I change the 100? No, that still stays as 10 squared equals, now we just have 10 to the 6x here. What happens again? 10s cancel, so we have 2 equals 6x. How do I solve this here? Careful. Divide by what's with x? Divide by 6. So we get x equals 2 over 6. What does that reduce to? What can I divide both of those by?
2.
By 2. So we get 1 over 3. Yep. Okay. The reason these are different is because I had 2 different problems. Okay. Go ahead and write this example off to the side of example 5. So we have natural log of x squared minus 16 equals natural log of 6x. Okay. What is something you notice about this problem compared to what we had before? Still think this one's in natural log form, right? It's not an exponential form anymore. Still think of the bases. What is my base for a natural log?
E.
Right. Do you agree both of these have base E right now? Okay. Same thing with what we did with exponential functions. If we have the same base, what should be in the parentheses? Should they be the same?
Yes.
Especially if we have an equation here. So we can do the same thing we did with the bases of the exponents. These are just going to cancel out since they're the exact same. So what do we have left? X squared minus 16 equals 6x. This is going to bring back flashbacks. Okay. We have an x squared and an x in a problem. What is this going to turn into? If we didn't have this x in the problem, we could end up taking the square root. But we can't since we have that x in there. It's the big F word, not the one you're thinking of. Huh? Other one.
Funny.
Fraction.
Factor. Oh my god.
Factor. When we factor equations, what do we have to have it equal to? We have to have it equal to 0. Okay, so to get it equal to 0, I want to get everything on the same side as that x squared. So what do I need to do with that 6x? How do I move it to the other side? Subtract. Yep. So I'm going to subtract 6x on both sides. Now watch how I write this left side. I'm going to have x squared minus 6x minus 16 equals 0. Why do I put that in the middle? Why do I put that minus 6x in the middle?
Because it has to go like in order.
Standard form, right? From highest degree to lowest degree. Nope, that'll get us farther away from where we're at. Now this is where we want to factor. We want to look for factors of 16. What are factors of 16? 1 and 16. 2 and 8. 4 and 4. So now, which one of those factor pairs gets us to add up to negative 6? Does everyone agree with 2 and 8? Do I need to change them?
Yes.
Which way? 8 has to be negative. Yep. How do I rewrite this once I pick my factors? Good. Yep. X plus 2, x minus 8, still equal to 0. What do we have from here? Solve. Yep. So we have x plus 2 equals 0, x minus 8 equals 0. How do I solve the left side? Yep. Subtract 2. We get x equals negative 2. Add 8. We get x equals 8. Now, what we're going to see when we have to factor, we can only have one solution here. We could have multiple, but remember we talked about extraneous solutions way back when? What does extraneous mean? Extra nonsense, right? So let's check. What I want you to do, one of the side of the equation was that natural log of 6x, right? Type in your calculator, natural log, put any negative number in there. Natural log of any negative number. What happens? Error. So, we cannot have a negative number of a natural log. So which of these, if I plugged it into here, would give me a negative? The negative 2. So negative 2 is not an answer choice. Okay, so our only answer choice is that x equals 8. Okay, well, what I want you to try is example 5a. So go ahead and try example 5a. You have log base 5 of x squared minus 45 equals log base 5 of 4x. What do you notice about both sides of the equation? Right, look at the base. What's the base? Base is 5. It's the same on both sides, so what can I do with those? Yep, cancel. So I'm left with x squared minus 45 equals 4x. I want to get everything onto one side, right? Because I have that x squared and I have an x. So what do I need to do with that 4x? Subtract 4x on both sides. So we have x squared minus 4x minus 45 equals 0. What do we want to look for here? Factors of 45. What are they? Okay, I agree. Jumping right to it. Do we agree 9 and 5 work? Okay. Do I need to change any of them? I need to go -9. So how do I write these factors? Again, the reason I went -9 is to get to add up to -4. X minus 9. X plus 5 equals 0. What do you notice, bless you, what do you notice happens when we set these separately and we get our answers? It's the opposite of what's in there, right? So -9 turns to +9, +5 turns to -5. What'd you say? -5 cannot be our answer because if I plugged it back into one of the sides, what happens? I get a negative, and in your calculator you get an error. So our only answer is x equals 9. So on the back side of your notes on the do you know how, we're going to look at example 4. So we have 16 to the 3x equals 256 to the x plus 1. So we have equation. We want to get common bases. What are my bases right now? 16 and 256. First, we want to see, can I turn our big base or our largest base into our smaller base? What I mean, can I multiply 16 however many times to get 256? Some of us said yes. Why are we saying yes? Right, and how many times do we multiply 16 to get 256? Twice, right? So 16 squared, and then we still have that x plus 1. Do I need to change the left base? No, because it is already 16. Okay. What do I need to do to that right side before I can start canceling some things out? Yep. So remember on that right side, I got to distribute. So 2 times x, 2x, 2 times 1, 2. Now we have common bases. What do I do from here? They can cancel, so I'm left with... Awesome. How do I solve this here? Subtract 2x. So we have x equals 2. So now moving on to number 6. How is this one a little bit different? It's the logarithms, right, instead of exponential form. But with logarithms, what's my base here? 5. Are they the same? Yes, so what happens? They cancel. What am I left with? Yep. What am I going to have to end up doing here? I got to get everything onto one side and factor. What do I do with that 7x? Yep. Where am I going to write that 7x? In the middle. Yep, standard form. Okay. What do we look for here? Factors of 44. Does anyone know them off the top of their head? Okay. Is that going to get us to 7? Nope. 11 and 4. Is that going to get us to 7? Yes. Which one needs to change? The 11. Yep. How do I write those as factors? Good. Okay. Trick. What's going to happen? X equals 11. X equals -4. Why is it not -4? Right. What I want you to understand, though, what if this was a -7 up here? So if this was a -7 on the inside here, and I plugged in -4, would that work?
Yes.
Why?
Because
It turns into a positive. If I plugged in 11, would that work? No, because that would give us a negative. So what I wanted to clarify there is just because this is a negative, that's not why it doesn't work. But in the cases we've seen, that's just what's happened. Okay, so our answer on this one is x equals 11. Okay. So last one for today, number 7, we have log base 2 of 3x minus 2 equals 4. What do you notice about this one here? There's no log on the other side, okay? How are we going to solve this then if we don't have a log or we don't have a common base on either side?
You put just add the x through it and just edit it.
What did we learn last week?
Put 4 in front of the log.
Okay, if we wanted to put 4 in front of the log, that 4 would have to be here. Good idea, though.
Oh, we can't do that?
No.
Can you do log 10 plus 4? Could you put 4 up?
How did we rewrite this?
How do we rewrite which one?
Let's put it into exponential form. What's my base?
1, 2.
Our base right on the left side is 2. What was the method?
Oh,
Circle. 2 to the 4th equals 3x minus 2. Why did that just help us? Why can we solve this one now?
Because we're using
Okay. Do I need to change a base or anything?
No.
No, because do I know what 2 to the 4th power is? We can figure it out, right? What's 2 to the 4th? It's 16, so we have 16 equals 3x minus 2. Now is this basic algebra. How do we solve? Add 2. So we have 18 equals 3x. Divide by 3, we get x equals 6. Okay, so what I don't want you to forget is that exponential form in rewriting using the circle method, that's always available to you. That is going to make problems easier when you get to those.